We're now in the run-up area and going to do the complete run-up per the King Air Academy checklist here for the C98. First thing is the overspeed governor rudder boost test. We combine that together. So the rudder boost switch is verified in the on position. I have both propeller levers full forward, condition levers low idle. I now reach down with my left hand and hold the prop gov test switch in that position. What I think happened is that the overspeed governor went from an overspeed condition, about 4% above redline, down to roughly the 2,000 RPM area. But I don't know, since at this power setting we're idling about 1,100 RPM. So now I'm going to take the left power lever, and I can do either one first, but I'll choose the left, and start adding power, and watching that all the gauges, fuel flow, N1, prop, torque, all going up. But when I hit about 2,000 RPM, that left side prop speed should stop increasing if that overspeed governor is working. I know the primary governor is waiting at 2,200 since the props go full forward. So there I can add a little bit more torque, no change in prop speed. There must be a governor holding it back, making the blade take a bigger bite. And I continue up. Usually it takes almost redline power to feel the rudder boost kick in that left rudder pedal. There, see, close to redline torque, left rudder pedal just went forward on me. Now let's see if I turn off rudder boost, if that'll release that left side. Yep, came back. So that's what I need to do there. I now will come back into power, release the switch, see that the governor is resetting. And at this point, to save a cycle on the engine unnecessarily, I'll proceed with some other checks before to the right side. And the next one is checking that the low pitch stop is set right. And for these raised-back props, we make this, excuse me, ground idle torque check at 1,800 RPM. Now remember, this is a fixed pitch propeller at this time, or no governor. And it says if that blade angle is right, at sea level on a standard day, and we're 1,200 feet here, 1,300 feet, and the temperature is right around the standard setting. But it's 500 RPM, so it says sea level 500, it should be that plus 20 minus 0. So that's real close. If the torque was much higher, meaning it's harder to turn that prop at this speed, it's because the blade's too big a bite, taking too much air bite. If the torque is low, blade's flatter than it should be. So this is a good check for that. The next part is ice vanes. Now for these pitot-cal airplane, all ground operation, we have the ice vanes extended. Engine anti-ice is on. But now in this nice clean run-up area, I'm going to turn off engine anti-ice, and we should gain a slight amount of power. And since we're not on the prop governor, fixed pitch propeller, we'll see the prop RPM go up slightly, and the torque go up slightly as we gain that power with more ram air in the cowling, since the ice vane is no longer extended. And I got maybe a 20 RPM rise, maybe 40 foot-pounds of torque. Now there are two actuator motors for the ice vane. I was on the main, so now I'm going to switch the selector switch to standby as I re-extend the vane, turn ice vane on, engine anti-ice on, using the other system then to drive the vane back down, opening the bypass door, and see if this comes back where it started from, drop in torque, drop in RPM. And light came back on. Looks good. So that completes this left side. Now I'll do the same for the right. Prop gov test switch up. Thinking the overspeed governor reset. Let's see if it did. Prop is holding. Torque continues up. Other gauge is going up. And right there I felt the right rudder pedal kick forward. It's a little lower on this side. Let's release the switch, see if the RPM starts to reset. It does. Come back to 1,800 RPM to make our low pitch blade angle check. Exactly the same as the other side. Perfect. Okay. Extend the ice vane, or rather retract the ice vane. I turn it off. Light went out. It takes about 20 seconds for the vanes to fully extend or retract. And I'm seeing the rise in RPM. Slight rise in torque, not quite as much the other side, which I can't explain. Now the other set of actuators, re-extend the vane. as I'm talking and doing this, I made a mistake on the other side. I forgot to do one thing. It's minor, but we might as well do it here, and that is check the primary governor. So in this raised back converted airplane, the primary governor goes all the way down to 16 instead of 18. So as I start coming back now asking for lower RPMs at 22, nothing happens for a while, but finally when I pull back far enough to have the governor go below 18, it should bring the prop RPM down with it. There it is. Primary governor's working, back full forward. And that completes that side. Next part of the run-up is the auto feather check. Now in many airplanes, especially the 3-bladed prop ones, it turns out that the power required to do this check, up around 500 foot-pounds of torque, will not cause us to get into the governing range. But we already saw in this airplane, 500 brings us up to about 1800 RPM. All we're trying to achieve here is torque, not total power. So I can make it slightly quieter and less total power being used to create the torque if I set the RPM at minimum. So for those of you who have not talked to us before probably don't know the little technique, but that makes it a little bit quieter and requires us not to use quite as much power on the run-up because we get the torque at lower RPM. Now I'm reaching out with my left hand and taking the other feather switch and holding it down against a spring. I'm using my thumb. You can use anything you want. And now I have it down in the test position. What the test position does is eliminate the switches in the power quadrant dealing with auto feather. Normally, if I reduce power, auto feather turns off because it knows I wanted to lose power. It wasn't an unexpected power loss. But here, no matter what I do to the power levers, auto feather keeps on working. So now I'm adding power until both auto feather lights come on. Now in the early airplanes, they're on the annunciator panel. Later ones, they're either in the gauge or in the digital readouts. And usually that'll happen slightly above 500 foot-pounds of torque. So there's left and right auto feather lights on. Now many folks tend to do this check too quickly. We want to do it slowly. So I'm starting on the left, doesn't matter. Coming back on power to see that the right light turns itself off, disarms first. So my eyes are going on the right side. There, just went off about 380 foot-pounds of torque. Somewhere around 400 is what you're looking for. And this. It's very important to make sure we see the other side turn off and nothing's happening to this side yet. Now continue back, and somewhere around the mid 200 foot-pound range, we should see this light go out and the props start to feather. There, lights out. Now notice the RPM. It starts to feather, but as it feathers, it takes the bigger bite, the torque goes up. So now it stops feathering, starts coming out of feather, but that makes torque go down. So it's just there cycling. Depending on how much slop there is in that switch and how far back you pull the power lever, you may or may not see a significant lower RPM. But it's very rare that we have so much slop in that switch that it will go all the way to feather with the engine still running. So you can see it just trying. So all we're looking for is the light going out, a bit of a cycling. Now I can't check the other side until I get this side back up above 500 foot-pounds. So up comes this side. Waiting for both lights to reappear. Left light's on, and there's the right light on. Now the right side, back slowly, looking for the left light to go out first. It does, right around 380 foot-pounds. Continued back to idle. The right light is blinking. The prop is trying to feather, and then coming out of feather, and trying to feather again. Then the last part of the check, which many people overlook, is if I abort a takeoff, even if the switches in here malfunction and stayed closed when I have the power lever back, I don't want the props to feather. That would sure increase my stopping distance without the drag of the windmilling props. So at this point, I want to take the left power lever to idle and see that it stops this one from feathering. No feathering whatsoever. So they both should return to the low idle setting. This airplane about 1100 RPM. Looking good. Now, of course, normally you do that much faster than I did because I was talking through what we were doing. So it's complete, and maybe the most important thing of all, remember to put that auto feather switch back up to arm. So that checks all the system except the switches inside the power quadrant. And normally these would just be checked on the takeoff roll. But for training purposes, let me now show you that it takes quite a bit of power before the auto feather arms. Typically that's up close to 90% in one. So I'm adding power in both levers together, looking for the auto feather lights to appear. And there's the left, and there's the right. A little bit more brakes, keep them sliding. And so you see here the N1, 88-89%. Torque about 800 foot-pounds in this case. In fact, if the props were forward, you'd see the torque would be closer to 600 or so. So that arm's fairly early in the takeoff roll. Some pilots have the misunderstanding that because they've heard the autofeather arms at 90%, it's 90% power. No, no, no. N1 relates to power, but not in a linear fashion. So as you saw, 89% was only less than half power here. There's the auto feather check. Next one is the manual feather check. A lot of times we do this taxing. We simply pull them back. And occasionally, not all the time, I'd let them go all the way to make sure they come out pretty much the same. And generally, if they're below 400 RPM, you can know for certain that the blade went all the way to the feather position. Nothing bound up and didn't let it get there. But with that blade flapping the air sideways now, you don't have much RPM. A quiz question that will always confuse people is ask them, well, what happens to the ITT when you on the feather? Well, it goes up, less air in the engine. Well, does it? Looking real close here, I'm seeing 480 or so here and about 470 there. Let's not come out of feather. While we're waiting, you can see that they feather rapidly, but it takes quite a while for the oil pressure to come back in the prop dome to flatten the blades. So they unfeather rather slowly. If you're going to use that technique to control taxi speed, make sure you get them forward well before you need thrust around this corner, because it takes a while. So what did the ITT do? Hardly changed a bit, but actually it dropped a few degrees. It's just silly. But remember, free turbine. What the front of the engine is doing has almost no effect on the back of the engine. So when I feathered, N1, fuel flow didn't change, same air through the engine, temperature basically didn't change. Amazing. Next, the auto crossfeed test. We're going to talk to you later today about why we don't recommend using auto crossfeed. But for the test, I'll put it in auto, simply turn off one boost pump. I should get a momentary blink of the fuel pressure light as I lose pressure. Crossfeed should open and allow the other pump to come across and reapply that pressure. Here we go. Left pump off. Momentary blink. Crossfeed open. Crossfeed, or boost pump back on rather. Crossfeed closed. Back to auto. Now we're set to the right side check. Pump off. Blink of a light. Crossfeed open. Pump on. Crossfeed cycled to reclose it. Excuse me. And I'm going to leave the switch in a closed position. Autopilots, they're different ones, different King Airs, so I won't take the time to go through all that check with you. Electric trim, more than one version of that. But for this one, I'm going to chart by checking half the switch and make sure there's no trim action. And give it enough time to really make sure nothing running. Now the other side. In this particular autopilot system, I do get a trim fail light, which triggers the red flasher when I do just that side of the switch. It's funny, it's not both sides, but that is normal. Now, let's take both together and verify the trim goes forward. It does. And back the other way, aft. The red button, pushed all the way down, should disconnect trim. So while it's running, take the red button one click, two clicks, all the way down. It stopped it. And on the panel up here, the light that says electric trim off, green in some models, yellow in others. And once that light's on, meaning we went too far with the red button, then it's a matter of reaching down the pedestal, take electric trim switch off, which kills the light, and back on, it resets it. Now the co-pilot will do the same check. Back on one side, nothing. Other side, or the same side the other direction, nothing. Other half the switch. Other half the switch. Both switches together going back. Both switches together going forward. Now, again, this is not true for every King Air trim system, but for most of them, it turns out that the pilot side has overridden the co-pilot. So while we're going forward on the co-pilot side, I'm going to then take my side switches aft, and the trim should reverse and start going up. Yep, it does. Let's try it the other way. Co-pilot going nose up, I go nose down, and it reverses direction, goes down. The last thing I want to check is the red button for the copilot side. So while it's running, his red button or her red button down, it stopped, got the light, cycle of trim on, and set for takeoff. So there's your trim check. Nowadays, of course, all airplanes have to have a TAWS, Terrain Awareness Warning System. And while we're doing all the other checks, might as well do that one too. So in this particular installation, there's the TAWS display. And I have a push to test switch here in the glare shield where they added the system. So let's push that in and release it.
EGPWS system OK.
And I heard EGP, Extended Ground Proximity System, test OK. And I get the test pattern on the display, and that clears itself momentarily. Back to normal operation. Showing a lot of red since we're sitting on the ground. Well, thanks for watching. That's the complete run-up. How often do you do that? Well, according to the POH, you're doing a first flight every day. To be honest with you, I do it about once a month, or if ever you suspect a problem. This airplane's going into maintenance as we take off and fly over to Havasu for our phase checks. And so I want to do all the checks to know exactly where we stand before it goes into the shop. I'll run all those checks again when they come out of the shop, make sure things are still working. That's it. Thanks.